Tomorrow will be better. A ball is shot towards a cliff at an angle of 40 degrees with respect to the horizontal and at an initial speed of 70 meters per second. First question. Given that the cliff is 150 meters away from the shooting point, find the time at which the ball strikes the cliff. And the second one, what is the height at which the ball strikes the cliff? Follow me, dear friends. Solution. The first thing in such questions is to identify what information you have. Because what information you have guides you into what formula to use in order to obtain what you want. We have what we call here the range, we have the angle of projection, we have the initial velocity. Now we are going to exploit the equation which relates the horizontal distance to the time taken and to the initial speed. And this is the third equation. I would say S equals ut minus half gt squared. Now an important reminder, we are talking about horizontal component of the motion. In the horizontal component, there is no g is 0. For this reason, this second component of the equation boils down to 0. We are left with only this. This is the first important reminder. Secondly, we have to take note that because we are talking about second dimension motion, this u is not the usual u we know. This u here, the initial velocity, will be the horizontal component of this, okay? So u is going to be equal to 70 cos 40 degrees. It's important to take note of this, all right? So with this in mind, we have this distance, which is 150, we have u, which is this, and we can look for t. All right, so we proceed here to say, therefore, t is going to be equal to what from this equation? Divide both sides by u. All right, so we will have that t will be equal to s divided by u. Therefore, let's substitute it. We're going to have that s, which is 150 meters, divided by u, which is 70 cos 40 degrees. If you punch this correctly, this should give you approximately 2.8 seconds. Now, how do we calculate the distance from the ground at which this ball strikes, strike the cliff? Because the ball will do something like this and strike the cliff. What we have to do now is, all of this motion, whether horizontal component or vertical component, is happening at the same time. Okay, so in essence, this time we've had here is the time that it takes to cover this horizontal distance here. Now we want to examine, after this time, at what altitude would this ball be from the ground? That is the altitude at which it strikes the cliff. Okay, so let us use this time. Let's exploit this time we just had to find the height at which the ball will be after this time. We will still use this same equation, okay? So we will say, this is the second part, s is still ut minus half gt squared. In case you're wondering why it is minus here, this is because the projection, the initial part of the motion starts by opposing gravity, all right? Gravity acts vertically downward, but initially this ball is launched vertically upward. So this is why we have a negative sign here. Be very careful. Now, what we are looking for in this other equation is s, the vertical distance from the ground at which there will be impact, or rather, the vertical distance that this ball would have covered after a time 2.8 seconds. Because this is what happens from 0 seconds, 1 point something, 1.2 up to 2.8 seconds. This is where it will be at this height. This is the height we are looking for, dear friends. All right, so we'll have that s is going to be equal to, now again, u is not just the u we know. U this time around is the vertical component of the initial velocity, which is given by this. So we will have 70 sine 40 minus half times, for simplicity's sake, we take g to be 9.8 and then times the time 2.8 all square. If you correctly punch this, you will boil down to s equals to 87, I think, 87 meters or 86.7 meters. Okay, so there will be impact at 86.7 meters away from the ground. Tomorrow will be better.